Okay, and a good morning to everyone. And that was Joni Mitchell. And Ernie, what were you listening to? Bad Dreams. You do not select well. You just sit back there and play music. You've got to do better. This is not good. No, come on. That's no excuse. We can do better. Now, going on in pre-algebra, the same words to you. You can do better. The quizzes I graded. You can do better. They are not as good as I wanted by any means. So with the test tomorrow, I'm going to try to get those quizzes out to you at the end today, and so you can have a chance to look at them. But in general, you should be doing better on those problems. And that's where you had to translate from a verbal expression to a symbolic expression, things like 7 minus a number, which would be 7 minus x. Or 3 times a number, or let's say 6 more than 3 times a number, 3x plus 6. And the problem with the isosceles triangle, where you're adding the sides together and getting a perimeter of 19, those problems did not go as well as I would expect. So a reminder, now that we have nearly a full group again, this is looking good. For those of you who are here for the first time in a few days, we've been having a light turnout. The test tomorrow, I trust you'll all be back. But let's summarize what we have for the test tomorrow. That's going to start in section 3.3. It's going to go up through section 4.5. And as I reminded everybody yesterday, that means that you will go through, and listen carefully to what I'm saying here. You're going to go through the problems in the text. Look at 2 problems from each section. Minimally, medium difficulty, and one a little bit harder. Take 2 problems from each set and try them. Work together on it with the idea of making sure that you can get those 2 problems correctly done. And what I've encouraged is that you write up some problems that way and exchange papers and compare with each other and spend some time studying together. Your biggest difficulty, pure, simple, and it's understandable given all the things that have happened in your lives. And they've been a bunch. But the simplest and surest way to prepare for this test is get together in small groups and work together several hours doing problems from the text. 2 problems from each section. Make sure you can do them. And then try to build up speed. You're going to have 20 questions in an hour. So roughly 3 minutes per question, much as we've done in the past. In addition to that, I've limited the number of word problems so that there are only going to be a couple of them on the test. So we spent last week really focused on word problems, translating, and so on. I had a couple days assigned to that, and I'm not putting it on the test to the extent we might. I'm going to do a little bit more with that on the final. But it was our first effort with word problems. This is a rather important test for several of you, meaning half of you, because some of you have, and as I say, I'm not being critical of why. I'm just saying the reality is some of you have missed enough that if you can survive this test and pull things together, you will have managed to sort of take the deck stacked against you and make it work. But you're going to have to spend time. So if there, and there are a couple situations where I have not had a chance to say this privately, but if there have been a couple situations I need to be aware of where you do not feel that you're ready for the test tomorrow, I can delay that for you so that you can get the time you need. And there are several of you that that relates to, but you'll have to check with me about that. Don't want to put you at a disadvantage. The bad side of delaying it is we do move on, and it makes it more difficult. But if there are, and I know there are, extenuating circumstances that may make it such that tomorrow would not be the best day to do it. Thursday, we are going to do our tutorial then, in which this is partly because of the schedule for Palomar, and we've adjusted to it. And so Friday we'll be covering new material in 5.4. Now, to the extent that I can get all of you to get that test done, then Thursday I'd like to spend time talking about the test, but if it turns out that I have to delay that, then I will spend the time in the tutorial in a different way. So that's where we are. For those of you who are back, we yesterday covered problems in 5.2 and 5.3. My guess is there are going to be questions on that. We need to do that today. I'm not doing any more review on 3.3 through 4.4. What I've suggested you do is about the best thing I can encourage you to do. My office hours are, as usual, 1:30 to 2:30 today, but we have bridge meeting at 2:30, so I will not be there from the 2:30 to 3:30. So to that extent, I'm not going to be available beyond my office hour. Thinking in terms of the computer work, I'm trying to remember, I think I had that open up until 11 o'clock today, and possibly even up through tomorrow at 11. Does anybody remember the cutoff in that? Is it 11 tomorrow? Okay, so it's sitting there, so if you wanted time to work on the computer, and that's in 5.2, 5.3, 5.1 you're supposed to have done already. So the computer portion in 5.2 and 5.3 open through tomorrow morning. I assigned, and this is what you need to hear for those of you who weren't here, I assigned problems from 5.2 and 5.3. Problems from 5.2 are due today. These were the problems that involve variables. Then 5.3 I had due on Thursday. And so if you're wanting to know what problems, just look at the exercise in 5.2, and if it's a problem with variables and a fraction, then it's assigned. If it's just an arithmetic problem, no, and they were all together as a group. So I guess the best thing to ask, and I ask you to hold on to your papers, although I guess you passed them over already. Well, that's okay. What I was going to do is ask what kinds of questions you had in those, and I thought it would help if you had them in your hand to look at that. And do you want them back so you can look at them for a moment, or you know what yours is? You want it back so you can look at it? Okay, so take your paper out. I appreciate your passing them forward, but if you held on to them a few minutes, it might be a little bit more meaningful. Dion? Yeah, it's going to come. Robert's going to pass them back. Kim?
So it's going to be all variable problems on 5.2 and 5.3?
For the homework that you're turning in. You still have the computer part, which includes some of the problems that were in Math 10, the problems just with numbers. The only thing that was a wrinkle there that I had not done much about, and perhaps it's time with all of you here today, at least it seems nearly all of you are here today, I should do a Brian question. If you aren't here, speak up, right? I think that's the classic. The question of estimating. So let's say that we had a multiplication, and this was one of the problems, and I don't know if this is exactly the one, but let me go to the board, Ernie. And the problem had to do with something like 3 1/4, and we wanted to multiply it by, and let's see, in fact I'm going to make that 3 3/4, if you don't mind. And this one I'm going to write as times, okay, give me a moment, I want something over 5. Let's see if I can do this. And I'm going to take, okay, 3 1/5. So 3 3/4 times 3 1/5. Now, we know that we're supposed to change those to improper fractions. But the idea is as an estimate, and I probably haven't done justice to this, but I like the numbers that are coming out. Can I do any better? 15, 3. Yeah, let's take this 3/5. I can do a little bit better than that. But the point is, this is close to 4 and this is close to 4. So if you did this one, you'd say, well, that's about 4 times 4, which is about times 16 when you get the product. And we should have an idea of what we're getting. If I'd left it at the original, 3 3/4 times 3 1/5, then I would have said this rounds off to 4, this rounds off to 3, and I should get about a 12. So that's part of what's being done in the problems before we get a correct answer. Bolvaro. I'm rounding off to the nearest unit. So the ones digit. 3 is between 3 and 4. 3 and 3/4 is between 3 and 4. It's closer to 4. This is between 3 and 4, but it's closer to 3. So I'm just, in a sort of rough way, making an estimate. And then I ask, when I do change these to improper fractions, do I get something that's reasonable? Well, this is going to be 15 over 4, and this is going to be 16 over 5, and I chose with malice aforethought, with the idea that I can cancel here, and I can cancel here, and sure enough, I get what? 12. Was my estimate good? Yeah. That was not designed. That was just luck. Robert? If you had 3.5, technically you can think of it like it's a half or more go up. If it's under a half, stay down or flip a coin. Statistically, it would make sense flipping coins. But okay, doing this one, this is again going to be 15 over 4. But this one is going to be 18 over 5. And so the 5s cancel. I get a 3, a 2 here, and a 9 here. And I get 27 over 2, which is only going to be what? 13 and a half. And am I close to 16? Well, I'm in the ballpark, but not very well. So that one didn't estimate as well. But that's the wrinkle that's been added we didn't do in Math 10. And you are, I suspect, going to be asked to do that in the computer, but I don't see it as an issue that I'm going to push on a test. Now, from 5-2, for those of you who are working in that. So, Michael, start with you.
Okay, with number 50, it was, well, my question was, it's 10 M7 and...
10 M7?
Yeah.
M to the 7th?
M to the 7th and...
N?
Yep, over 30 M9 N4.
30 M to the 9th?
9 to the 4th.
Whoa.
Oh, N to the 4th.
Okay. I was going to say, now do I have it right? P to the first, still here?
Yeah.
Okay, any more? That's it?
Well, yeah, my question was, though, since the P is the P going to stay on the top, or would I put it on the...
You can choose, can't you?
I put it on the bottom.
Okay, I've heard several suggestions. Yes, you can choose. Yes, it can stay in the bottom. In terms of the request that's going to be made of you on the computer is to do it with positive exponents. So if you're going to play it with those rules, then you have to have P to the first in the bottom. If I wish, first the 10 over the 30 becomes a 3 down here, correct? I'm going to list that as into the first. Now, with that in mind, this is M. I thought I was in the numerator and wasn't. M to the 7 minus 9, N to the 1 minus 4, and since I don't have the letter P in top, I just leave that alone for the moment. Now, as I've said yesterday and last Friday, I'm using this argument that A to the M over A to the N is A to the M minus N. And if you get a negative number for an exponent, you have to understand we have made an agreement in mathematics. Nothing more than agreement. We make the agreement because of this rule. But when I do this problem and simplify, I have M to the minus 2, N to the minus 3, and 3P by itself, or P to the first. Now, the agreement we make is that N to the minus 3, so note, N to the minus 3 is 1 over N to the third. That is what we agree to. Just an agreement. No magic to it. So if I have this and I want to rewrite it, then the first thing I observe, technically there's a 1 out in front of this always. We don't write it, but it's understood to be there. So I could rewrite this as 1 over m squared, 1 over n cubed, times 1 over 3p. That is, I'm just breaking this into m to the minus 2 times n to the minus 3 times 1 over 3p. These are all over 1. So this can be rewritten like that. Now this becomes what you would have, and I forgot the 3. No, it's there. Okay, I thought I left it out. This is what I suspect you would have in the computer as a preferred solution, where the alphabetic order M, N, and P are there, and the 1 is understood but not written. And then somebody told me, I think it was Bomaro, that you may have to put dots between these for the computer to accept it. Computers are terribly unforgiving. They are programmed to accept something in a precise form. You leave out 1 dot when it's a marginal or optional, and it won't accept your result. So part of your problem here at times, I regret to say, is playing a game of second-guessing how it was intended in the computer. Michael, what was your question? Going ahead.
So if I put the P on the top, that's going to 1.
Okay, let's go back to where that letter P can be. Technically, it's P to the first here, correct?
Yeah.
The only way I could put it in the top is if I had this as an answer. I could have written m to the minus 2, n to the minus 3, p to the minus 1, all over 3. Because p to the minus 1 would give you 1 over p to the first. And so some textbooks talk about taking a factor. Now, if you will allow me to consider m squared as a factor, even though it technically is m times m. But if you're going to take it from here and put it up here, you have to change the sign. So it becomes m to the minus 2. If I had an n to the minus 3 here and I want to put it down here, then it becomes n to the third in the bottom. And so they try to make it into a rule. All I ask you to remember is, what does p to the minus 1 mean? 1 over p to the first, and that's where it would have been. Now, back to your question. Could I just have had p in the numerator by itself? No exponent, and the answer is no. Okay? Jessica?
I have a quick question. I'm not sure if it's not right, but
Okay, quick questions.
say the equation or the...
Are we talking about expression or equation? Expression, okay.
Is it starts off with a negative? Will the answer always be negative, or will it...
Okay, so the question is, if I start off an expression with a negative, such as negative, and I'll just say 5x to the second, y to the negative, I better not do that. I'll just put this as to the fifth. And I'm going to place that over a 10, and I have an x to the fourth and y to the third. And the question I'm being asked, will I have a negative in the answer if I start out with a negative? Well, in this case, I would have a negative in the answer, but what happens if I have a negative down here? Then it would be a positive in the answer. Now, what happens if I were to do this to you? Now, we talked about that yesterday. Okay, but now, notice that's a negative there, but it's to a second power, so that means you're going to have a negative times a negative, and that's going to make it a positive answer. So you have to be cautious.
So, but if I don't have the parentheses...
If you don't have the parentheses and you just have a negative there, you're in business.
Okay, so, okay.
Okay.
I just wanted to make sure.
Yes. Now, for those of you who just saw that and went, ooh, there's a 1 there. Okay, and we talked yesterday about having a to the m to the n. And that became what? A to the mn. You multiply the exponents. Okay? So if I do that, and then this question, if you have a, b to the n, that is a to the n, b to the n. So putting those all together, this becomes, in the numerator, minus 5 to the first, all to the second, x to the second, to the second, y to the fifth, to the second. That's still just doing the numerator, so that's minus, that'd be a positive, 5 squared, x to the fourth, y to the 10th. Just in the numerator. Now, if you don't like multiplying those, just write this down twice, because that's what the 2 means. Write that whole thing down, and then write it down again. And you have x squared times x squared. You have a y to the fifth times y to the fifth. That would give you y to the 10th, x to the fourth, and you'd have minus 5 times minus 5, which is 25. Richie.
How would the 5 be a positive?
I had negative 5 quantity to the second. So that means negative 5 times negative 5. That means I've taken the product of 2 negative numbers and get a positive. But if I have the 2 out here, that means I had negative 5 times negative 5.
Yeah, but you're only multiplying with the exponents.
I'm not, no, wait a minute.
Well, 2 times 1 is 2.
This means the same as this. And both of them are going to come out the same result, positive. And here I'm going to have, you can say 5 squared, or 25, but this is also going to come out 5 squared. So the exponent in this tells you how many times.
Afterwards, after you've already multiplied the exponents and...
Now hold it, be careful. I'm going to make a distinction between 2 things here, Richie. One, I can multiply the exponents. That's a choice. Or I can say that exponent tells me to write whatever's in the parentheses twice and multiply. Okay, good. 2 different ways of approaching it. Now,
So if it was a 3 instead of a 2, then it still would be a negative.
yes, if this had been a 3, this gets back down to the question, if that were a 3, I would have had a negative 5 times a negative 5 times a negative 5, which would have been negative 5 to the third. Now, this is pushing you a bit beyond a pre-algebra. Nonetheless, it's one of the problems in the set of problems, one of the last ones in our text. But this is pushing you over the edge. I won't give something that bad like this thing on the test. But you have to be cautious that you understand how exponents are being used. And Rishi's question is a good question, because this can either be multiplied across using this rule, or you can just think of it telling you how many times to write whatever it's attached to in a product. So if you see a 2, you write the factor twice. If you see it 3, you write it 3 times. Probably the most critical issue here is in this statement. Okay, Ernie, camera 1 here for a moment. I need to free up because I need to talk about probably the most serious question relating to Jessica's statement and Richie's question, both at the same time. And as soon as Ernie gets the camera settled and he starts the other rotating, okay, I'm going to disappear from there for a moment. And I'm going to make a very critical distinction. If you go on in mathematics, this distinction is very, very critical. The difference between these two. Now, this says take the inverse of x and then square the result. This says square the result and then take its inverse. And what we get caught up in here, I'm going to evaluate these two. Let x equal minus 3. Now the first one becomes minus, then minus 3 to the second power. because it was the x that was squared, and x is minus 3. And I had a minus sign out in front of that, so that's minus. This is 9 inside. That gives you negative 9. In essence, in the real numbers, I'm cautious here, in the real numbers, this will always come out a negative result. If I allow you to go into the complex numbers, a set that you'll hit in an intermediate algebra class, and sometimes in a beginning algebra, you could get a positive there. But as far as you're in the usual set of real numbers, this will always come out negative. This will always be positive. So even when x is minus 3, it's minus a minus 3 all to the second power. Okay? So a negative of a negative 3 will just be 3. And so that is 3 to the second, which is 9. That distinction, that one problem, is very, very critical as you go on. For right now, you can afford to blow it occasionally, but it's a very critical problem. Other questions on the homework? We've managed one question and one kind of change of the problem. Sandra?
Okay, I knew how to figure out problems, but in the intermediate step, I didn't know how to write.
Okay, can you give me the problem we're talking about?
Okay, it's problem number 44 in the book.
Number 44. Okay.
Negative a to the 4.
Am I writing what you intended?
Yes.
Okay.
B.
Right next to it?
B, yeah.
Times b.
Over a to the 3rd times b to the 5th.
B to the 5th. Okay, now with the statement we just made about the negative x squared, this is the inverse of a to the 4th. So whatever a is, positive or negative, taking it to the 4th power would result in a positive. So I'm going to have a negative in front of that. This is Isaac's unseen 1. Now if I put that 1 in there and proceed to go ahead, I'm going to get minus a to the 4 minus 3, b to the 1 minus 5. That's the intermediate step I'd like to see.
Okay, so
Let me finish here. That's a to the 1st, b to the minus 4, and then I'd like to see you go one more step, minus a over b to the 4th.
that's what I got.
Now you could go technically from here to here without the intermediate step. I'd like to see the intermediate step.
Okay. So I did everything like you did, but the question was, I was still trying to keep it in a fraction form. So would I put a line under the intermediate step? We have negative a, 4 minus 3. That part, would I put it over 1?
Yes, you could.
Okay, because that's what I did.
Yeah, you can put those over 1. No problem. You can always put the 1 underneath.
Okay.
Kim, you had a question. This,
So I have been here, so we're gonna,
but we missed you.
we're going to
Okay.
minus the 4 and 3. That's
The
part
subtract the exponent here from this exponent when you're dividing.
Okay, I've done that. We've done that.
Yes. Okay. I saw another hand go up, and I just didn't pick up on it. It was over here. Who else was it? Okay, Marisol, and then I'll be with you, Michael. You mean as far as an intermediate step, should I have both of these before you get here? You did this and this one,
I did those,
and then you jump to here.
yes.
You can do that. I think the minute you commit yourself here to b to the 1 minus 5, it's important for you to see that that's b to the minus 4 before you putting it down in this step. Now, again, I want to... Let me try to make a fine line here. I could be expecting this just what you might call being pedantic, being a pedant. It's sort of like somebody in education, you do it this way because I told you to. And that's not the issue here. The issue is I want you to succeed in 70. That's what this course is about, succeeding in the next course. And if you do some of these intermediate steps, my experience has been that you do better than if you skip them. Because when you write them down, you're doing more than happens when you just think it. One of the great problems is to be able to think something through in your head and an hour later recover it. No matter how clever you were, it's a very difficult thing to do. How did I do that? Gee, that was good. How did I do it? But if you document it and you write it down, there's some kind of activity that seems to take place between the physical part of writing it. And I very firmly believe at this point, the larger you write, like big motor movements on the board, stick with you better than if you're sitting there with a pen writing in a minuscule level font that only you can read with a magnifying glass. That there's something with a physical option here that you're doing that makes it stick. So to me, intermediate steps are good. With that said, what's the downside of it? If every time you do a problem like this, you have to go through these intermediate steps, then pretty soon you are not learning to go quickly. There's got to be a balance. Because there has to come a time when I go from there to there in my head. Right now, I don't think it's quite that time, but I use the analogy of training wheels on a bicycle. Eventually, you got to kick them off and ride for it and take the risk. Right now, this kind of intermediate step makes sense to me. If you find that you battle it and you refuse to do it, okay, so be it. I'm not going to take a point off because I don't see that one. Nancy.
What if we just write the whole thing out, like, you know how it says a to the fourth, or negative a to the fourth?
And you write a times a times a times a? No. Otherwise, if you're going to want to do these just without the exponent, and you're going to do this, Sarah and I got into a discussion about this.
Because on the...
I know, just a minute. I'm going to argue why no, although Sarah asks her students to think this every time they do it. That's a lot of writing. And so my rebuttal to Sarah over dinner, before dessert, was, well, what happens if I have a to the 57th power over a to the 80th power? Are you still going to do it? Well, no. But I have them think like they're going to do it. So there's a point for it. However, I don't want to see this going on at this level because you get carried away there like I did. And now you say, gee, I've got an A there, and I have a negative there, and I've got 4 of those guys there. No. You've got to go from here to here. This will get you through this course. This won't get you into the next course. You have to be able to deal with the exponents. So pay your dues. Other questions? No other questions on the homework problems then? Okay. Wait for me to do it. Okay, James, and then come up with a question. Go ahead. Must be the trip to San Diego that does that.
Y to the second.
8y to the second.
Y to the first is Y.
Still on the top?
Yeah.
So I have an 8.
8x to the second.
Okay. But you understand why when you said y to the second y, it did not seem reasonable. 8x to the second y. Z to the third. Over. Negative 32. Oh, okay. What number is this? 52. This will be our last one we'll look at. Okay, does it seem reasonable in the denominator I'm going to have a negative 4? Just a comment. We do not leave negatives in the denominator. It's not well behaved as a mathematician. Okay? Not wrong, it's just not good form. It's like saying you're eating your steak with your hands when you should be using a fork. There's etiquette. So the etiquette says, instead, I'm going to make a minus on the top and make the 4 down here. Or, if you don't like the minus there, just put the minus in front of the whole fraction. But we tend not to leave a minus sign in the denominator. Haven't brought that up before, but just trying to teach you manners. These are mathematical manners. Okay? Next. Do you understand why I want this as x to the first? Okay, so I want that as x to the first, I want this as y to the first, and I'll answer a question before I continue.
So if you got a negative sign in the denominator?
In the denominator, I'm not taking it off, but I'm telling you it's bad etiquette.
No, but yeah, we can put it in front of the whole fraction.
Yes, you can. It can go in 3 spots. It can go in the bottom, it can go in the top, or in the front.
And it's all right.
They're all correct. The bad one, as far as form, is the minus sign in the denominator, Sandra.
What's the difference between the one on in the numerator and the one out?
Well, in the numerator, it says you have a numerator that's a negative value, but out here it says you have a negative fraction. So it would be, as a point, negative 3 over 4 says I'm taking the ratio of 2 signed numbers. The numerator's negative 3, the denominator's 4. This says I'm going to take the additive inverse of the fraction 3/4. Now, numerically, they're the same value, negative 0.75.
So it just means the same thing, just different ways of writing it?
Yes,
Okay.
they mean the same thing, different way of writing it. Ernie, since I was talking about that, we might want to shove over just a little bit so I can pick up this, thank you, and down just un poquito, there. So I have these two mean the same thing, just different ways of approaching it. Now back to here. I would then say x to the 2 minus 1, y to the y, sure. Y to the 1 minus 4, and z to the 3 minus 3. I like that intermediate step. Then this gets back, Marisol, to your question. I would like to show it in between and say I have minus x to the first, y to the minus 3, z to the 0, all over a 4. Where I understand that z to the 0 is 1 as long as z is not 0 itself. That's a restriction.
So the z and the z don't cancel each other out.
Well, they do. What's z to the 0? 1. Do you recall when we were working with expanded notation and we said you could have 4 times 1 or 4 times 10 to the 0? Anything other than 0 to the 0 is 1. Well, you don't have to be bitter about it and hit James. Now, carrying this through, am I done? Not in terms of the computer. Because the computer would expect you, and this is where I don't know whether they want that sign. You know, that question, Michael, that you brought up, it could go in 3 places. I don't know how the computer's been programmed, whether they want it in the bottom, the side, or the top. They want it in the bottom? It would make sense because that's where it was, but I don't like it. But if I'm trying to get full credit in the computer, I'll do it. What? I would not take points off for where you put the minus sign as long as it's in one of the 3 accepted positions. If you put it up here in the wall, not acceptable. James, I'm not done here. You have a question before I finish it up? I can go ahead. Okay. X to the first. This is understood to be a 1, and that 1 there is optional. This is over 4y to the third, so my guess is it would be written as minus then x over 4y to the third, and you don't even see the z. James had his hand up first.
What if you put a 1 in front of x?
A 1 in front of the x. A 1 in, like this? I'd say that's fine. Now the computer might not like it because 1 times x is x, and we think of having as few symbols as possible, called paucity. Few symbols as possible to write an answer. Sandra.
That was my same question. Because the reason I wanted to still put the 1 there is because I'm like, well, I still need the fraction part from the numbers, so I figured I had to put a 1.
So you had it as negative 1 over 4 or 1 over negative 4?
That's negative 1x over 4y to the third.
Okay. What is different? I'll take this one off here so we don't have it repeated. What is the gain? I'm not sure I'm following you why you wanted the 1 in front of this x here.
Because I ended up with 1/4 from the original problem from the numbers.
Okay, so if you had a 1/4, you pulled the 1/4 out in front
Right.
at some time. Okay, I can buy that. So you had a negative 1/4, then you had x to the first, y to the minus 3, z to the 0.
Right.
I'm comfortable. But again, part of the difficulty, if you put a 1 in there for the computer, it might not accept it. So if you're sitting there and saying, boy, I got this right, I'm sure of that, computer's not accepting, ask yourself, What are your options? Here would even be one that would, I'm sure, blow the computer away totally. Minus 1x to the first over 4y cubed. And my guess is you put that in the computer and it's just going to go, no,
Yeah, I know.
even though it's correct. Kim?
Why does the y as no power go to the bottom?
I had a y to the minus 3 up here, correct? Our agreement. So this is an agreement. That y to the minus 3 means, you can tell I've been working with a cell phone with an unlimited screen and everything scrolls right down. So means 1 over y to the third. Okay? That's an agreement we make. Just an agreement.
They already put it on the bottom?
Yes,
Okay.
to the positive exponent.
Okay.
We make that agreement.
So you only need 1 on top, is that why? Or
No, that's just, when I subtracted here with this rule, remember it was a to the m over a to the n, we subtracted the exponent. So I end up with a negative exponent. What does it mean? Okay, so if I take camera 1, Ernie, hold it. Do I want to do that? I've got to stop and think how I want to do this. Scratch that.
on the note?
Ernie, let's slide over this way. When I had b to the first here and b to the fifth here, correct? I end up with b to the fourth in the bottom when I cancel. Now this is the same as taking, as I slide over a little bit further, when we did it we said we have b to the 1 minus 5. But we know we end up with what? The b over here, don't move anything, b here 4 times. So this evidently has to mean b to the fourth is down here. So we make an agreement. Whenever you see a b to the minus 4, you will understand it means over b to the fourth. Be careful. It's not the additive inverse. The exponent is. But this is giving you a reciprocal. This is Richie's reciprocal without using a 1. So if I want the reciprocal of 3, it's 3 to the minus 1. Listen to that statement again, because this is a place where you can get burned. Note, 3 to the minus 1 is 1 over 3 to the first, which is 1/3. So if you want the reciprocal of 3, just take it to the minus 1 exponent. That is an important observation. Okay, now are we done with 5-2? Okay, will you please pass those back over towards Robert? I'm going to go back up center, Ernie. Leave this where it is. Okay, so I don't know how comfortable you are with what we just did homework-wise, but we're going to look at 5-3 now. Oh boy, a recliner for a desk. Robert, you're too laid back. I'm going to see you down in the movie set with the recliner and the umbrella out, and we'll never be able to talk to you again. Okay, I'm at page 329. Okay. Let me have a moment here, Ernie, while I get some cards set up here so we can isolate what I want to isolate. Okay, here is a problem that we're isolating out. There it is, 53. Now, this is taking, in some ways, the step before the problems we just had on the board. That is, okay, Ernie, where I have number 52 to the right of the clock, number 52, right side, if you'll come to that just for a moment. This problem right here, this mess I have, you might ask, where would I get a mess like that? With all these things top and bottom. Okay, now come back to the document cam. Somebody asked you to do a product like that, and so if I take what's in the document cam and say, I have 9m to the third, then I'm going to have times a negative 15, and then I'll put that in parentheses, and then I have an n, and in the denominator, I'll write what I have there, 25 n to the fourth, and I have an 18 n to the m to the second. I would probably, as we come to the board, write this first as a negative, and I don't know if I would be inclined to say negative 135 m to the third n over 25. This, oh mercy, just a moment. Okay, I've got to think that one through as a simple way of doing that. So if I had 16, that would be 450, I think. 450, am I right? And then I have n to the fourth, and I probably would do it alphabetically and have this. Now, otherwise, I've multiplied this stuff together where common sense says do what? Cancel. But note, this is the kind of problem we just looked at, where you're supposed to then say m to the 3 minus 2, and you have a 1 understood here, so that's n to the 1 minus 4. And then, of course, at this point, I did something bad to the extent now that I've multiplied all that garbage together, you're supposed to reduce it. It would have been a heck of a lot easier to sit up here and say, well, 9 went into this, went into here. You had 5 going into here, 5 into here. And so we know that that's going to be 3 over 10 with a negative sign. But the point is, this would be a result of what we see on the document cam again, where you're multiplying two things together. Now the question, as I write the problem the way it originally was, let's come back there a moment again, Ernie. I had 9m to the third, and this brings up a question of how do you avoid making a mess of it? Let me first write it, and then I can show you what I want there. Negative 15, and I have an n, and that's over 18m squared. Now, do I have to write it this way before I can start pulling things together? And the answer is no. So what do? Well, I'm not real happy with saying I'm going to cancel that and cancel this and get into the third in the denominator. Technically, you could. Again, what I can say is n here and n to the fourth is going to cancel, giving me n cubed in the denominator. Well, I can look at this and say I have an m squared there and an m cubed there, so I'm going to have an m in the numerator. Then I can do the canceling we talked about here, and I end up with a negative 3, and here I have a 10, and that's exactly what I'm getting here, because if you look at this, I have my negative 3, m to the first, n to the minus 3 over 10, and these are different forms of the same problem. I'd like to look at what the text is doing to see what the intent is as you do this for the computer, because it's so easy. Do you put the 1 here or not? My guess is not. My guess is this is going to be the preferred form to go in the computer. Now, you're doing this for me in paper, but if you do problems like this computer, unfortunately you don't have very many of them to do. You're going to have to play with the notation to see what works. So I'm going to leave that. Come back to the document cam if you would please, Ernie. What I'd like to do now is look at an example. That, by the way, okay, I'll get to your question in a minute, Michael. That was one of the moderate level difficulties. Just for those of you who were looking at what I did in the board with the exponent and the outside, just a reminder that this problem is what we looked at earlier. That's number 66, where you had a negative 2xy to the fourth over z to the third, all to the fifth power. Okay, so that's a little bit on the extreme, but you should be able to handle that. Now, Michael, your question.
My question was, why why the parentheses, why the multiplication sign, then the parentheses around the fraction?
Okay,
The second part.
back to the problem on the sideboard there, Ernie. The question is why that parentheses up here, and if you reflect just a moment, pull the parentheses off, take out the dot, and what does it look like? 9m cubed minus 15n. Now it looks like I have a binomial rather than a product. Even though they're technically two fractions, you're misleading visual cue because you see the 9m cubed, you see a minus 15n, and you just ignore the fact that they're two fractions you're multiplying together. It's just be cautious, be safe, don't confuse, try to avoid it. Does that answer for you?
Yeah.
Huh?
Would they word it a different way? Would they say, like, simplify the... How would
Okay, good question. Richie's asking, what would be your direction here? It could be from simplify to find the product. Usually it would be simplify, writing your answer with positive exponents. But that's what I want to look at and see what the text is doing. So let's come back to the document cam one more time and try to deal with the question that Richie is asking, which has to do with what is being done. Boy, that's interesting because they just say simplify. If I come to the document cam, this is the question that Richie's asking, and it doesn't say with positive exponents. So I'm not sure if the computer is going to accept a negative exponent. My guess is no. And then I'm going to try coming back to a problem that's being illustrated and see if there's anything here that gives us an idea. If I look at example 7, just as an illustration, this was simply simplify. Now, there wasn't a product involved here. We'll look at another one in a moment. But this is just to simplify, and notice at the end, this is what's done. Rather than multiply through, rewrite. This is where, Richie, coming back to your initial question, I mentioned you had a choice to multiply through the exponent or to simply write that, what we think of as that base, 3 times. I don't like this particularly. I think you're able to go beyond that, where this is 5 to the third. This is, again, you have to be careful because you have to have a 5 to the first, y to the first, all to the third. So that would be 5 to the third, y to the third, negative, then 2 to the third, x to the sixth. I think you're capable of doing that, and I don't think this is serving you well. But the intent here is not to get in particularly to what I did, and Ernie with camera 1, coming back to these right here, if you would, with camera 1 just for a moment, and then I'll come back to the document cam so you can recenter. But if we come to here, we're getting there anytime. Camera's not agreeing with you. Okay, I have these 3. I want you to use those. And those are technically in 70 level. But we're at a point where I think if we're going to play this game, do it the way it should be played. Make it work for yourself. And coming back to the document cam, and then back center. To the document cam, if you feel that you want to check yourself, try doing it this way. No, back to the document cam. Do this and give it a shot. Then come back to what we did with the exponents, multiply them, and see if you get the same answer. I guess the comment I'm making here, don't trip through this stuff fast without thinking about it. The more you spend time on it and the more you work at it, the more you're going to get out of it. And I think Sarah's comment is one that, as we discuss this, because we're both teaching a 20 right now, and her comment is, if I pull off what I'm trying, you're going to be very well prepared for 70. Very well prepared for it. If I back off a little bit, then I'm not preparing you as well. And my advantage is this simple. Out of 10, your background with the fractions and such, I don't have to battle. With her class, half the class, more than half the class, just tested into it. Didn't have the background, and so she's battling that on a constant basis, and it makes a difference. So see what you can do with it. Make the problems work for you and try to do it in as sophisticated a way as you can and get as much mileage out of it as you can. I'm out of time. I do want to get the quizzes returned to you after we go to the camera. We're going to go to Joni Mitchell, and so Ernie.